Welcome grade 9 to lesson 5.3 on adding polynomials. Now the key to adding polynomials is to understand what goes together and what does not go together. And these are called like terms and unlike terms. Now if you have any misunderstanding or you're not quite sure what I'm talking about, you have to go back and re-watch lesson 5.2 because without knowing what goes together, you can't add them together. So let's start out with tiles first and then we'll go on to the symbolic after that. So when you see a question like this, 2x squared minus 3x plus 4 added to x squared plus x minus 2, you'll notice that we have a whole series of terms here. Now the only difference between what we were doing before was that they didn't have brackets around them. They were just one long line in 5.2. So the same thing happens here. We're going to draw the tiles that for each polynomial. So this is 2x squared, so that's two large squares. Negative 3x, so that's three negatives, which means they're shaded in, and it's a rectangle, and 4 ones. Going to the next tile, set here, the next polynomial, we have one large, one rectangle, and two negative ones. So what we have to do now is we have to take a look at this and say, okay, what can go together and what cannot go together? Well, you'll notice the x squared tiles are all positive. So there's nothing that cancels out. So the result of adding these together is 2 plus 1, which gives you 3 large tiles, or 3x squareds. Now taking a look at these, the x's, you've got 1, 2, 3 which are negative, and you have 1 which is positive, which means that this is going to cancel out one of these 3. And it's going to end up going away to 0. You're going to leave the other 2. Now the last one is these 4 positives and these 2 negatives. So these 2 negatives are going to cancel out 2 of the positives. And that is going to also go away. So once you have this all cancel out, you can now take a look at what's left over. Right? So we have the 3 3x squareds, we have our x's, and we have our 1's. So all we have to do now is change this back into symbolic, which means variables and numbers. Well, 3x squared is written 3x squared. That's pretty straightforward. Now remember, this is negative 2x, or subtract 2x. And of course, 2 left over is plus 2. All right? Let's go to the next one. All right? Now we have x squared plus 3x minus 5, and x squared minus x plus 3. So taking a look at modeling the first one, x squared is just one big square. 3 x's right there, and negative 5 is 5 negative 1's. Modeling the second one, you have x squared, negative x, and 3 positive 1's. So now that you've got them modeled, if I was marking this, it would be model and model. There's your first 2 marks. All right. Now, moving on to the next part. I've got to rearrange things. X squared and x squared go together. And there's just 2x squareds. 1, 2, 3 x's and 1x, so 3 take away one of them, means that these one here, they're going to go away, leaving just the 2. Now, the next one is our 5 negatives and our 3 positives. These 3 positives are going to cancel out 3 negatives. And of course, they're going to go to 0 also. So redrawing everything that's left over, we have this left over. Now the last thing to do is to convert them into polynomials, which are in according to their degree. So the first one, x squared, there you go. There's 2 of them. 2 x's and minus 2. Right? Now when I'm marking this, it's going to be, did you model this one correctly? Right? Did you zero out everything correctly? All right, so I would be looking for this and this. All right. And of course that's 1, 2, so we got 4 marks so far. Did you redraw it correctly? And then did you get the right answer? 1, 2, 3. So that's how it's going to be marked. All right, moving on to the next one. Let's get rid of the tiles and let's do just symbolic. And this is where we really have to rely on 5.2. And did you understand what goes together and does not go together? Okay, so take a look at this. We've got 2x squared and an x squared. Now these two are like terms because they have the same degree, 2, and they have the same variable x. So they go together. This is an x and that's an x, so they have both got an exponent of 1. That means they have the same degree and they have the same variable x, so this one and that one can go together. And of course the constant 4 can go with the negative 2. Now don't remember that is a negative 2, not just a 2. So when we do this, we take and write them, put the first one over top of it, and then everything underneath in the second polynomial goes under its matching term. So the x squared goes under the 2x, the x goes under the minus 3x, and the negative 2 goes under the positive 4. All we have to do now is just do some adding. 2x squareds and another x squared gives me a total of 3x squareds. Now, this is, remember, a 1. This is 1x right there. So a positive 1 and a negative 3 leaves me with a negative 2. And a positive 4 and a negative 2 leaves me with a positive 2. Now, in this situation, because we don't have tiles, what I'm looking for is your setup. And then, of course, 1, 2, 3. So we're talking about 4 marks or something like this. Moving on to the next one. All right, I want you to try this one. I've already set it up for you, so all you have to do is just do the addition. So pause the recording and do the addition. All right, now, x squared and an x squared, that gives me 2 of them, so I have 2x squareds. This is a negative 1, remember that's a 1 there. So positive 3 and negative 1 gives you a positive 2, so I have plus 2x. Negative 5 and positive 3 leaves me with negative 2 left over. So marking this, set up, mark, mark, mark. All right, pause the recording and try this one. All right, now, taking a look, we've got negative 24a and 12a, so this is going to give me a negative 12a when we're done, and it's squared. Positive 12a and negative 5a, that gives me 7a, and a negative 21 and a positive 12 gives me a negative 9. All right, try this one. Pause the recording and do it. All right, so negative 4y squared and 2y squared, well, negative 4 and 2 gives you a negative 2y squared when you're done. 7y, removing 3 y's out of that, so 7 take away 3 is 4 y's left over. And I have a positive 5 and a negative 6, which means when I put them together and cancel them out, I'm going to have 1 negative left over. All right? Now, let's just do a quick check and see if you can answer these for me. I want you to put a yes or a no. Can these things be combined? Because from now on, you're going to have to line them up. So pause the recording and go through 2x and plus 2x squared. And on the line here, I want you to put yes, no, yes, no, yes, no, no, whatever matches. Can these be put together? Can these? And put yes or no. So pause the recording and do that. All right. So first thing we need to do is take a look at the variables, x and x, so that matches. But when we look at the degree, this is a second degree. And this one here is a first degree. Remember, a first degree is a variable. We don't put the 1 in, but it's always there. So this is first degree, this is second degree, which means these two cannot go together. X squared, y squared. The degrees are the same, but the variables are different, so no. X and x, the variables are the same. They're both first degree, so this is a yes. 6, which is a constant, and 3x, well, this doesn't have an x in it, so obviously, if it doesn't have an x, you don't have the same variables, so that's a no. 2x, so we have a variable x, I have an x here, but it's an xy term. It's not an x, it's an xy. This is an x, so this and this are not the same thing. Remember, if we were doing in terms of degrees, this would be x to the 1 and y to the 1, which makes this a second degree because 1 plus 1 is 2. So a first degree term on the first one and a second degree term on the second one means it does not get combined. Now over here, I have x squared, and this one here is x to the 1, y to the 1. So this is a second degree also, but this is a variable x. This is an xy. They're different. So this is a no. So in order to make sure you know what you're doing, here's the rule. In order to be combined, the terms must have the same variables and the same degrees. Okay, now what I want you to do here, I guess I've already organized them for you. So let's see how you do on this one. Pause the recording and set it up and do it, okay? Okay, so taking a look at this, I've already taken and I've rearranged everything for you. The x squareds go together. Now, there's a thing over here at the end which is interesting because if you take a look in the first polynomial, there's a 3y there. But there is no 3y there. So that means this one can't have anything underneath it. There's no y term in the second polynomial. So doing your addition, 3x squared minus x squared gives me 2x squared. I have a negative 3xy and a positive 2xy, which means I have a minus xy. If you put in minus 1xy, that's okay, but since we know there's only one, you don't have to put the 1 in. 4y squared and 2y squared, 4 and 2 is 6. We have 6y squared. Negative 2 and positive 6 is a positive 4. And the 3y has nothing to combine with it, so it just goes in as 3y. Okay. If I was marking this, it would be set up, and then each one of these would give you a mark. So we got 1, 2, 3, 4, 5, 6. All right, so if you had anything here out of order, you would lose this mark here only. Okay, so let's take a look at the next one. I want you to pause the recording, and I want you to do this one. All right, so taking a look, we've got, there's our first polynomial, and I've taken each term and put their like terms underneath the top one. So for example, look for the a squareds, there's a 4a squared. The ab's, there's a negative 6ab. B squareds, there's a, right here, oh, there's a 3b squared. So I've done that for all of them, so hopefully things lined up. Now, taking a look at 3a squared plus 4a squared, that's a 7a squared. 2ab and 6ab means I have, and this is negative, so negative 6 and positive 2 is negative 4ab. Negative 4b squared and 3b squared means I've got negative 1b squared, or just b squared. 3a and 0, positive 3a and negative 3a, these all cancel out, so you have a 0. And a 5b and a negative 3b, that gives you a 2b. It's positive. And of course, negative 12 and positive 5 is negative 7. Right. Now, the last thing to do is organize these things the way they should be. All right. Now this 0 goes away because you don't include it. So what we really have is this right there. Now, organizing them into proper terminologies, we take a look at the squares. Okay. I've got a 7a squared, so that's my first one, 7a squared, and now I got to take the b squared because we do the purest first, right? That's b squared. All right. Now, this is a second degree, but it's not a pure. So this is a 4ab, so it's minus 4ab. It's hard to write with a mouse. And then I have my first degree, which is 2b, so plus 2b. And of course, negative 7. Now, when I'm marking this, normally what happens is this. If you set it up correctly, that's right. And then, of course, going through here, you get marks for all of that. And then, of course, when that's done, I would go directly to here. Right? And if you got all of these in the proper order, you would get a mark. I'm not going to mark them wrong because they're out of order and give you, mark off 5 marks. So you're still looking at 1 for the setup, 2 for all your additions. You have 1, 2, 3, 4, 5, 6, right? So we've got 1 and 6 is 7, and of course, putting everything right is 8 marks here. All right, now you had to put yours in order. So here we go. I have mine put in order. I put my 3a squared minus 2b squared minus 3ab, and I just put them up there. I don't know why I swapped them around, but I did. Don't worry about it. Now I went here, and I found out this is a 4a squared, so that's got to go under my a squared column. I've got 5ab, so that goes under my ab column. But I don't have any b squareds here. So the b squared's got to be the only thing in its column, right? And really, what we have down here is nothing more than a 0. So you can actually think of this as plus 0. And over here, I don't have any constants in my first polynomial, so that's also a 0. Right? Now, we don't normally put them in, but if you want to put zeros in as placeholders, go for it. All right, now, I've got to take a look and do some adding here. 3a squared and 4a squared, well, that's pretty simple. That's 7a squared. ab's, positive 5 and negative 3 leaves I have 2 ab's left over. B squared's in nothing, give me a b squared. And nothing in 6, give me a 6. All right. Now the last step, I've got to put these in order. 7a squared comes first. All right. And then we have to take away the 2b squared because that's the other pure one. Plus the second degree. This is the second degree also. That's your 2ab. All right. So I've got all that plus 6. All right. Taking a look at the next one. Pause the recording and do this one. Kind of got them in there so you can see them. Keep forgetting that I should cover this up. Well, hopefully you did it on your own. So here's my first polynomial, 3m squared minus 3mn plus 5n squared. And I moved way over here because I knew that I was going to have a bunch of variables in here, but the last one was going to be with a constant -2. Then putting the second one in, 2m squared, that's in that column. There is no mn, so that's a 0 there. There is no n squared, so that's a 0 there. There is no there is no n in the first one, so that's going to be a 0. There is no m in the first one, so that one's going to be a 0. So taking a look at my columns, I've got 3m squared and 2m squared, but that gives me 5m squared. Now, there's nothing for this to do, so this becomes -3mn. There's nothing here to add, so that's 5n. There's nothing here to add, that's 6n. There's nothing here to add, that's 7m. And there's nothing here, well, yeah, we can add this one. 5, take away 2 is 3. Right? So now, making sure everything's in the proper terminology, or the proper degree, we have 5n squared. Plus, here's my other second degree, 5n squared. Okay, so I've got, put it the wrong one. All right, so this is the squared here. Okay, so the 5m squared is done, the 5n squared. Looking for the other second degrees right here, we have a -3mn. And now I can look at my first degrees. M comes before n, so that is plus 7m plus 6n. That's supposed to be an n there. And of course, plus 3. There you go. Okay, the other thing they like to do in the achievement test is they like to take addition of these polynomials, and they like to put them into a question where you have to find the perimeter of a shape. So what I've done here is I've taken a typical one that comes off of the provincial achievement tests, and here is a triangle, and you've got x plus 3, x plus 8, and x plus 10. So what we need to do is to take all of these, and we have to tell what we're going to do. So we're going to take the first x plus 3, then we're going to take the x plus 8, and then the x plus 10. So that's our addition. Now when you put them all together, that's 1, 2, 3 x's, and 3 and 8 is 11, plus 10 is 21. Right? Now the other thing they do here is they will take and say, okay, if the perimeter is equal to, say, 42, what does x equal? So what they want you to do now is say, okay, if the perimeter is 42, what is x? So now we have to solve for x. So first thing we do is we take away 21 from both sides. Okay, this becomes 0. So on the right-hand side, I have 3x. 42 take away 21 is 21. And of course, now I can divide by 3. So in this case, x is going to be equal to 7. All right, pause the recording, and this time I want you to do this by yourself. Remember that if they have the same marks, that they're the same. So this is a single, that's a single, so this is also an x plus 4 right there. All right? And this is a double, and that's a double, so this one here and that one there are the same. So let's have you do this one. Pause the recording and do it. Okay, well, the first thing you need to know is, okay, what have we got here? Well, I've got x plus 4. I also have another one over here, which is x plus 4. And I have another one over here, which is x plus 4. This one here is x squared plus 2x plus 3. So once I know what all of them are, I can take a look and say, okay, what is this going to be when I add it all up? So my first one is going to be my x squared plus 2x plus 3. And then as I go in this one up here, this is also the same thing. So I'm going to put these right after each other. And now I've got 1, 2, 3, 4. Oh, sorry, those are supposed to be -4s. Okay, x minus 4. I forgot. I looked at that and got it wrong. X minus 4 and x minus 4. All right, so taking a look at that, x minus 4, x minus 4, x minus 4, x minus 4. Right? Now the last thing, put them all together. We have 2x squareds, which gives me 2x squareds. We've got 4x and 4x, sorry, 2x and 2x, which is 4x. 5, 6, 7, there's 8 x's. And I've got a 3 and a 3, which is 6. But then I've got negative 4, negative 4, negative 4, negative 4. This is negative 16, and positive 6 means I have minus 10. All right? Marking this, I would be marking your setup and, of course, your 3 terms. We will see you in the next lesson. Take care.